I'm Anil Kumar. In this video, we'll discuss about odd and even functions. Now in books you'll find a small space given to odd and even functions, but every time in a test paper there may be a couple of questions based on this concept. So let us try to understand what is an odd function and what is an even function. Let me begin by sketching few diagrams. So I'll sketch some odd functions and some even functions, and then we'll try to figure out their properties, right? So let me sketch some odd functions and even functions. Odd function could be a straight line. Now that is a good odd function, a straight line, y equals to x. Even any other line going through the origin is an odd function. Even function, parabola y equals to x squared, is an even function, right? So let me also write down the equation for these. So it is y equals to x, and this one is y equals to x squared. Now there are more examples, and cubic function, which is y equals to x cubed, is also an example of an odd function, and the sketch of that is kind of like this. Y to the power of x to the power of 4, y equals to x to the power of 4 quadratic function will be an even function, but this time I'll give you a different type of an example, and I'm giving you this function, which is an absolute function, right? So y equals to absolute value of x, always positive. So a line reflected, the left side of the line, left side of origin, has been reflected on the x-axis. So minus of x has become plus x, so it becomes even function. Okay, some other examples. There are many examples. I'll cover few of them here. Sine wave. What do you think? Sine wave is an even function or an odd function? Well, sine wave is an odd function. It's kind of like this, right? So it extends to this side and like this. Do you see it is symmetric about the origin? So that is an odd function. Cosine wave, which is kind of like this, is an even function. Do you see that? So that is even function. Now that brings us back to what differentiates between even and odd function. How can you say from an equation or otherwise from the graph that the function is an even function or an odd function? This is a question for you to answer. Think about it. Okay, so what we notice here is that if you see, let's start with the even functions first. If you notice, all these graphs are symmetric about y-axis. They are symmetric about y-axis. That means there exists a point here which is a mirror image. If I reflect it on the y-axis, you get a mirror image, right? So everywhere you would reflect, and it is about this y-axis. So you see that. So that is a major characteristics. Looking at the graph, you can say that even functions are the functions which are symmetric about y-axis, right? So in even function we can say that they are symmetric. Let me write here. About y-axis. Okay. How about the odd functions? What kind of symmetry do you find here? The symmetry here is a point symmetry. So basically you'll say it is an orientation symmetry. The graph of an odd function has rotational symmetry about origin. So here the symmetry is rotational symmetry. So from the graph you can say whether a function is even or odd depending on its symmetry. So that is how you can figure out from the graph whether a function is even or odd. If this kind of symmetry is not there, then the function is neither, right? So let me sketch some functions which are neither, right? So that will give you a better idea of this topic. So we could get, if I displace this function, it doesn't go through the origin, for example, then it's neither even nor odd. Now you can see the symmetry is not along the y-axis. The line of symmetry has changed, right? So it is neither even nor odd, right? So that is one way of creating or sketching a graph of a function which is neither. For example, this line also I could draw like this. Now it is no more symmetric about the origin, right? So that is how we can actually see from the graph and say whether a function is even or odd or not. Now the question is, how can you algebraically prove whether a function is even or odd? Well, you need to find the value f of minus of x, right? So that means the negative value. If it is same as in this case, right, f of x, let's say this value is some value a, and this value is minus a. So if x is a, you get a value. If x is minus a, you get another value. If they are same, that means f of minus x is equals to f of x. In that case, the function is even, okay? However, here what you notice is that for a, the value is a, but for minus a, it is minus a, right? So if f of minus x is equals to minus of fx, in that case, the function is odd, right? So that is algebraic reasoning, right? So that is algebraic. We will call it test. So I'll have another video where we'll give you a few functions and you need to test whether they are even, odd, or neither. Now let me give you some examples here, and you need to figure out whether this function is even or odd, and how do you know whether it is even or odd. So this function, I hope it reminds you of a reciprocal function, which is y equals to 1 over x, right? So this function here is y equals to 1 over x. Now can you tell me what kind of symmetry this function has? It is symmetric about the origin. Do you see that? So therefore it is an odd function. So it is an odd function, and also you will notice that f of minus x is minus 1 over x. So algebraically you can prove that this function is an odd function, correct? Now let me give you an equation which is say y equals to 3x, let me write 3x cubed plus 2x plus 1. This function, will it be even or odd? Well, you notice that there are some even terms here and some are odd terms. These two terms are odd terms. Do you see? X and x cubed. However, 1 is an even term. So since it is combination of even and odd, this function is neither. Now, it is an exercise for you to sketch the graph of a constant function y equals to 1 and check if it is indeed an even function. And here is the solution, right? So if I had to sketch graph of y equals to 1, it should look like this. This horizontal line which has y-intercept at 1 is y equals to 1. You can see it is symmetric about y-axis. So that is what I meant. I hope with this video you have a fairly good idea about even and odd functions. You can check from the graph whether a function is even, odd, or neither. Also from an equation you can figure out whether a function is even, odd, or neither. I'll give you links for a few videos to test even and odd function and explore more. Go through these links and learn more. You can subscribe and share my videos. Thank you and all the best.